Okay, so 8A, let's get rid of this, and we'll go to 8A. 8A, here's your noble gases. They are very unreactive. They are gases at room temp. What else can I say about them? That's about it. Okay, the two rows of elements at the bottom of the periodic table, I call those the rare earth elements. They're also called transition metals. Let me call those inner transition metals. All right, inner transition metals is what I should have said there, because the transition metals are right in the center, so I got to be careful to distinguish between those, so make sure you caught my error and you fixed it. Inner transition metals, they have high luster, meaning they're very shiny. And since they're metal, they conduct heat and electricity well. All right, I'm going to get rid of that and scroll on down, so if you need to write it, you might want to pause. So let's roll on down. All right. So here we are on number 22. Okay, 22 says there are two naturally occurring isotopes, and they want us to find the average atomic mass. So this is that weighted average I was talking about a while ago. So I'm going to take 0.75, change my percentage to a decimal, multiply by 35 for chlorine, 0.25 times 37 for this isotope of chlorine. When I multiply 0.75 times 0 times my 35, I got 26.25 AMUs. And then I multiplied 0.25 times 37, and I got 9.25 AMUs. And I add those up, and I got 35.5 AMUs. Do the same thing here, 95%. All right, so I have 95% of 14 nitrogen. And then I have 3%, which is 0.03 of 15 nitrogen. And then I have 2%, 0.02 of 16 nitrogen. So I multiplied 0.95 times 14, and when I did that, I got 13.30. And then I multiplied 15 times 0.03, and I got 0.45. And then 0.02 times 16, and I got 0.32. And when I added those, I got okay, let me see if I can do this. There's a 7 there, a 0 there, a 14.07 AMUs. All right, now it says a mystery element Q is a lustrous solid and a good conductor of electricity. Big, big clue. That's going to be a metal because it conducts electricity. Okay, number 25, I went down and I said, well, this is vanadium. Symbol is V. How do I know? I looked up atomic number 23. My number of protons is 23. My number of electrons is 23. My neutrons are going to be 51 minus 23, which I think is 28, if I can do math still. And then I looked up this one here, number of protons, told me atomic number was 14, electrons were 14. Mass number, I added those two numbers to give me 28. And I looked up number 14 on the periodic table, and I got silicon. Calcium, I looked on the periodic table, it's number 20, which means it has 20 protons and 20 electrons. And then 40 minus 20 gave me 20 neutrons. And I did the next one, the electrons were 12, so the protons had to be 12. These two numbers added together to give me the mass. The atomic number was the same as the protons and the protons and the electrons, because I'm doing 8-man. Can't say that enough. If you don't know what we're doing, do the 8-man. So I'll explain to your notes. Okay, 47 protons, 47 electrons, 47. So 108 minus 47 is 61, I believe. And I looked up number 47 on the periodic table, and I got silver. And this one we should have gone back up here and said was magnesium. All right, so let's move on. Okay, you should have seen these before, and we're just going to keep doing them because it's just a tool we're going to use all year. So 55.5 miles per hour. Notice I put the miles in the numerator and then hour at the denominator. And they want me to go to inches per second, so I'm going to say, well, 1 hour is 60 minutes. And then I'm going to say there's 1 minute for every 60 seconds. And then I'm going to say, okay, that takes care of the time. Get rid of those and those. Now I got to get out of miles, so 1 mile is 5,280 feet. I want to go to inches, so I can say that 1 foot is 12 inches. Get rid of that, that, and that. So now I have inches per second, so I know I'm good. Now I look at my significant digits, and I had 3 of them there. So if I multiply 55.5 times 5,280 times 12, and then divide that answer by 60 and divide that answer by 60, I got 977 inches per second, and that's the correct number of significant digits. So unless I made a math error somewhere, there's the good answer. All right, the density of an object is equal to mass over volume. Mass is 120 grams. Volume is 30 milliliters. So the density is going to be 4 grams per milliliter. Water has a density of 1 gram per milliliter. So I think this thing is definitely going to sink because the water is not dense enough to support it. Okay, let's go on to the last part of the test. Okay, so here you were given some data, and you were asked to do some things with that data. Okay, so first thing you have to realize is mass goes over here, and it's in grams. Volume goes down here, and it's in milliliters. So I need to mark these off. And I went all the way up to 90 because I know my mass goes up to 90, and I did it by 10. So here's going to be 10, 20, 30, 40, 50, 60, 70, 80. And I'm going to do the same thing here, 10, 20, 30, 40, 50, 60. So there's my 60. This is my 10 and my 20, and I'm having trouble labeling these because I've written down there, but I think you can get the picture. All right, volume is 0, mass is 0. Volume is 10, so I go to 10 and I go up to 15 and make a mark, and then I go to 20 and go to almost, travel on up to almost 30. All right, and then I went from 30. I plotted it at 45, so there's 30. 45 is about right there, but I'm a tiny bit above it. 40 and 60, so there's 40, and I'm going to go up to my 60. And there is my 50. So if I follow 50 up, it should be around 75. And then finally, my 60 should go all the way up to 90. It looks like I've got a mistake right there, so let me fix that. Kind of hard to do this with the... All right, so let's see, there's 70, so 75.2 looks like it'd be about right in there. All right, so let's see, I'm going to try to draw with a ruler. So let's go down here and see if I can find a ruler, and that'll help me. There's a ruler. Not sure that I want that, so I'm going to try a freehand shape. All right, so I want to go, and this is going to be kind of hard, but I'm going to do, and I'm going to change my ink color so maybe you can see a little bit better. All right. Yeah, I don't like that so much. So let's see, can we get rid of that? Great. Okay, well, let's go back and do it again. I'm going to pause and just do this in the last, I'm going to actually start a new recording.